Alright, welcome back guys. Now, these remaining parameters in which we are to know and understand. I don't just want to assume that we all know what RAM means. We might know it, but we might not be able to define it. And we might not really understand what it is, but we are solving for it. So now, all these things here, and we try to make it very simple for anyone hearing it for the first time or knows it before but don't really understand it, we understand today. Okay, so stay tuned. Alright, now for Q, what is the value of Q? We have two parameters remaining for this particular formula, which is also going to give us number of moles. So now, this first one is called what? Quantity of charge. Quantity of charge is the measure of electric charge. Listen, quantity of charge is the measure of electric charge representing what? The amount of electric charge transferred. Alright, take note of this definition. Now, aside from this formula that relates number of mole, quantity of charge, and F, we will talk about F later. There is another formula which can also give us Q, which is a quantity of charge. And that formula says that Q is equal to current times time multiplied by time. That is, current times time will give us a quantity of charge. So now that Q is what we call quantity of what? Charge. Now in stoichiometry, this formula is not quite popular. We might not come across it, but it's actually rare, but we might come across it. So I want you to be prepared for anything. Now, for F, what does F denote? What is F representing? This simple F is what? Faraday's constant. Now, for this Faraday constant, remember every constant has its value. Okay, so now for Faraday constant, is also called what? Molar charge of an electron. Molar charge of electron. Okay, take note of that. So I'm going to write first before we define. Faraday's constant, also known as what? Molar charge of an electron. Okay, molar charge of an electron or Faraday constant represents the amount of electric charge carried by one mole of an electron. Take note, they didn't say substance, they didn't say molecule, they didn't say an atom. They said what? Faraday's constant or molar charge of an electron represents what? The amount of electric charge carried by one mole of what? An electron. Now, that's a very simple definition for Faraday's constant. Now, as I said, all constant has their value. Now, the value for this guy is what? 96500. That is 96,500 and what? Coulomb per what? Mole. Alright, this is what the Faraday's constant, molar charge of an electron. Okay, so now this guy here is what? Measured in what? Coulombs, right? This guy is a coulomb per mole. Okay, so now on that note, what next? Now pay attention. As I said, finding the equation that relates these two might be rare in stoichiometry, but we can also see them. Okay, anytime you hear equation like something like what is the amount of electron, or what is the or talking about mole, electron, anytime you hear electron, if you don't hear particles, atoms, molecule, and you hear electron, know they are talking about this. We are going to come across questions like that when we are solving, so stay tuned. Okay, so now it remains what? RAM, called what? Relative atomic mass, relative molecular mass. Let me write it down. I'm going to give you a very good definition and explain these things in detail. We might know what they mean, but we don't really understand them. Okay, relative atomic mass. This guy is what? Relative molecular mass. Alright, what is relative atomic mass? Relative atomic mass is the number that tells us how heavy an atom is related compared to what the lightest known element or atom. I come again, relative atomic mass is what? A number which is used to tell how heavy an atom is in relative to what the lightest known element, which is what? Hydrogen. Now, to be more specific or to be more correct, we say 1/12 of what? Carbon 12. Okay, now don't be confused. Let me bring it in a way that you understand this properly in a real life scenario. Now, for example, I want to make a fruit salad or I'm having something to do with fruits, but I have a skill, but this skill is not working properly. So how do I measure? Because I want to measure what I'm actually doing, so that I don't I want to record everything down. How am I going to be able to do it? Now, take note, relative atomic mass is just a ratio, it's not the actual value. We are trying to relate it by giving it units. So it doesn't have a unit. Now let me explain what I mean. Now I have a lot of fruits. I now picked the smallest fruit in my basket, and for example I'm using a berry. Now I'm going to use that smallest fruit. I'll call it the lightest fruit there, the berry, this little berry. I'm going to use it as a reference fruit, the way the scientists use hydrogen as a reference atom. Now take note. Now when I pick the berry, I say the berry is what? Now forgive me, I'm going to write here. Let's say the berry is unit 1. Let's say the berry is what? Unit 1. And we also have an apple there. So now we have an apple also. So now how am I going to calculate this apple in reference to the berry, which is the smallest fruit in my basket? Now I weighed the apple and I noticed that this apple is 16 times heavier than the berry. So now I now give apple what? Unit 16. I also have what? A what? Pineapple. Okay, no. Let me use what? Watermelon for an example. Let's use watermelon. Okay. I think watermelon is bigger. Now, let's use watermelon. I weighed the watermelon. And now observe, in respect to the berry that I first checked, I noticed that this watermelon is what? 23 times heavier than the berry. Now, do you understand? This same thing I did here. I was trying to compare, they are trying to compare this other fruit with the berry, which is the smallest. That's the same thing the scientists did with the atoms. They saw that hydrogen was the lightest atom. They tried relating what? Other atoms to it. Like now, we use hydrogen as our reference atom. Now I need to clean this out. Give me a second. Okay. Now, scientists use hydrogen as their unit 1. Okay. Now they observe that what? Oxygen atom is what? 16 times heavier than what? Hydrogen. They also found out that sodium is what? 23 times heavier than hydrogen. That's how we came about what? Relative atomic mass. You understand? It's a number used to what? Check how heavy an atom is related to what? The lightest known atom. Or to be more correct, 1/12 of what? Carbon 12. Okay, so now let's move to relative what? Molecular mass. Relative molecular mass is like group of atoms summed together. We already like group of relative atomic mass. Sum is, in fact, is just the sum of relative atomic masses of different elements put together in what? In a molecule. Do you understand? It's like group of atoms holding hands together. Or like group of friends, they are working and they decide to put their hands together. It's the same thing. That's what the atoms are doing in relative molecular mass. So all the atoms are holding themselves. So we will now calculate all of them together to call them relative molecular mass. Now, let me give you an example. For example, I want to sew garri. I now brought what? I brought 1 cup of garri, I brought a cube of sugar, and I also brought groundnut. So now the smallest thing there is what? Let's say, give me a second, let me clean this board. Alright, so now as I said, now we have what? We have what? 1 cube of sugar. So let me just write it. Sugar. 1 cube of sugar, right? Now the cube of sugar is what? Let's just say 1 sugar. That's what? That's the smallest thing there. So we now call it what? Our unit 1. Okay, we also have groundnut. 1 groundnut. Now this groundnut is way heavier than what? Is way heavier than the sugar. Let's say this groundnut is 16 times heavier than the sugar. Now our cup of garri. Now 1 cup of garri, we observe that this 1 cup is what? 23 times heavier than the sugar. Now, and as I said earlier, what are we doing? We want to do soaking garri, right? So now we are going to mix everything together. But after mixing everything together, they now form what? The soaking garri. But alone, they are not soaking garri, they are just different items. So after mixing them together, what do we do? To calculate what I have eaten is what? Now I will punch my calculator. I say 1, which is what? 1, which is the sugar, plus what? Our groundnut, 16, plus what? Our cup of garri is what? 40. Okay, so our total is now what? Our total is what? 40. Now this is our relative molecular mass. The relative molecular mass of the soaking garri is what? 40. I hope you understand. Singly, they are what? Relative atomic mass. But if I put them all together, as I mixed my groundnut and my water and everything, it will become what? Relative what? Atomic mass. Okay? Sorry, relative molecular mass. So now I'm going to clean this thing so that we explain what? Empirical formula, molecular formula, and finally percentage composition. Alright guys, now looking at empirical formula, what is empirical formula? Empirical formula is the simplest ratio of an atom in a molecule. Is the simplest ratio of an atom in a molecule. Now what do I mean? Now I'm going to use a molecule and a compound to explain this thing. Now we know this compound, right? H2O2 is what? Hydrogen peroxide, oxygenated water. It's also known as oxygenated water. So now, this is what? The actual value of atoms in the compound. This is what? The molecular formula. To get the empirical formula, what do? We notice that everything here can be divided by 2 because there are 2 hydrogens and 2 oxygen. So obviously we can go by 2 go here 1, 2 go here 1. So our actual our ratio, our simplest ratio will now be what? HO. Do you understand? Now let me use another example. Let's use what? C6, H12, and O6. Hope we know this compound here. This is what? Glucose. Now we want to find the empirical formula of glucose. We notice that there is a common factor here, which is 6. 6 go here 1, 6 go here will give us 1. This hydrogen here, there are 12 hydrogen here. If 6 also go here, we have what? 6 going to 12. We are going to have 2, right? So now, what will be our empirical formula? It will be what? CH2O. Yeah, CH2O. You understand? 1 carbon, 2 hydrogen, and what? Oxygen. Okay? So now I define the empirical formula. Let me define what? Molecular formula. Now, molecular formula is the actual value of atoms in the particular compound. So now, I have indirectly taught you empirical formula and molecular formula. This is the molecular formula. This is the empirical formula. Take note. Sometimes the empirical formula can be the same with what? The molecular formula. Okay? Now, for percentage composition, we cannot do stoichiometry and avoid percentage composition. Okay? Now, for percentage composition is the amount of a certain element is the percentage of a certain element in a compound. Percentage is over 100, right? Now, what is the percentage of a certain element in a compound? Like, let's use a compound like what? Okay, we have the compound here already. We have what? Hydrogen peroxide. How many percent of oxygen is in hydrogen peroxide? That's what we're talking about. So we have to what? Calculate what? Oxygen over this compound. We now divide them and get our answer. That's what we're trying to say. Okay, so alright, so now we have finally finished all these parameters. What is the next thing to do? Now we have to apply all these parameters I've given to you. Hope you have been taking note of all these things. We have to apply all these parameters in our equation. Okay, alright guys, with everything I have explained, I believe that we can be able to solve this question ourselves. I don't have to solve this question for you. Now, the only thing I will have to do, I have to give you the spoon so that you use the spoon to eat. Okay, so now in this question, they say what? How many moles of corrodium are there in 3.4 grams of the compound? Now they give you the thing you have to note is what? Corrodium. What's corrodium? Now, grams, we already know that what is mass. They're giving us mass. We need the what? Molar mass of the compound. And we are looking for number of moles. So automatically we already know that this is what the formula we are going to use in this question. Now, what is corrodium? Is a ore of aluminium. Now I'm going to just help you guys, okay? But I'm not going to solve. Okay, so now corrodium, the formula for corrodium is what? Al2O3. Alright, now this is the formula for corrodium. The only thing you need to do is to calculate what? The molar mass. The molar mass is like calculating what? The relative molecular mass. So with your atomic masses, you calculate what? The relative molecular mass. Same thing. So you just have to what? Calculate all the whole atomic masses and get your molar mass. So now I'm going to give you this value. Normally in questions like this, you will likely see the values of what? The element. Aluminium is what? 27. Okay, then oxygen is 16. But it's good for you to know them so that you don't run into trouble. Okay, all right. Now I believe we're able to understand the basic concept of stoichiometry. Now make sure you share this video to at least one person. If you have a lot of friends who are also going to be needing a detailed teaching on what stoichiometry and a well-arranged teaching like this, make sure you share this video to them or refer them to this channel so that they can be able. And don't forget, the most important thing you have to do now is to what? Click the subscribe button so that you can be able to see videos like this, more videos on stoichiometry and other topics in chemistry. So please click the subscribe button, like this video, and also don't forget the most important thing. After solving this question, as I said, I'm not going to solve it for you. Provide the answer in the comment section. I will make sure to reply every single comment in the comment section. Okay, thank you for watching. Now I believe that learning doesn't have to be boring, it has to be fun, and mostly fun. Not mostly fun actually. Okay, so now check your sweet drop, it's always there. Thank you for watching.
I'm saying rubbish. Isn't that what I'm talking to? So I'm saying rubbish, Abby. I'm saying rubbish. I'm saying rubbish. That's why you turned off the chain. That's why I'm making noise. No problem. Just be doing words in your mind. This is how you want to behave in this relationship. I will leave you.